Hello, welcome to this episode of the Classics. Today I will be talking about the Wallis integrals and the Wallis product. So let's take a look at the question. For all values of n, Wn equals to the integral between 0 and pi and 2 of sine to the power n x dx times and that integral by changing the boundaries. So if you do like u equals x plus pi and 2, you'll get also this thing with the cosine. So it's pretty cool. Actually, this part doesn't matter, but it's just part of the question. So the goal is to prove that w of n equals wn minus 2 minus 1 over n minus 1 times wn. Then to prove that sine x divided by x equal to the product from 1 to plus infinity of 1 minus x squared over n squared pi squared, and then to prove that pi equals 2 times the product from 1 to plus infinity of the 4n squared over 4n squared minus 1. So we take that and we notice that sine to the power n equals to sine times sine n minus 1 dx, obviously. So we'll do an integration by parts. We state that we call u prime equal to sine x, so u equals to cosine. V equals to sine to the power n minus 1, so v equals to minus n minus 1. The n minus 1 comes from the power, times the derivative of sin, that is minus cos, so which is why there's a minus sign here, and then this to the power to the power less, so we get sine to the power n minus 2. So wn equals to this thingy minus this integral. So this thingy actually equals to 0, because when you evaluate cosine in pi over 2, that will be 0, and when you evaluate sine in 0, that will be 0. So this whole thingy means 0. So you have a minus sign, it equals to a plus sign. So you factorize by n plus 1 here, so I put it here, and you have cos and cos, so you get cos squared. And then this is just stupid step. Then we have cos squared x plus sine squared that is equal to 1. It's a well-known formula. Then we replace the cos squared with this equation, and we get the integral of 1 minus x squared times sinus sine of to the power n minus 2. So we get that wn equals to n minus 1 times, we get 1 times sine n minus 2 for this one here, because we split the integral into two integrals. So this is actually wn minus 2 since the definition here, and the other part is sine squared times sine n minus 2. So this is equal to the integral of between 0 and pi and 2 of sine n x dx, and that is actually equal to wn. So we get this relation, and this is exactly what we wanted, so it's pretty cool. So for the next question, I actually kind of cheat, but it's technically a proof that works. I say by the factorization of Weierstrass, I say that sine x equals to x of the products of 1 minus x squared over n squared pi squared. So this comes from the identification of the poles of the poles of the sine. So it's pretty complicated, but factorization of Weierstrass works. So you get this, you divide by x, and you get that sinus x over x equal to this product, and then you evaluate it in x equal pi and 2. So x equal sine pi and 2 equals 1. 1 over x equals to 2 on pi. So you do that here and you simplify. Here pi squared over 4 divided by n squared over pi squared. The pi squared simplify, and then you get 1 minus 1 over 4n squared. Then you simplify, you get pi and 2 equal this, and then you get that pi equals to 2 times the product of this. You get this by the inverse, by taking the inverse of this. And yeah, that's it. So we've proven that pi equals to twice the product of all numbers, all numbers squared times 4 divided by 4 times their square minus 1. So that's it for this Wallis integral and product. If you're interested by the factorization via stress, it's actually pretty interesting. I recommend checking that out. And if you have further questions, feel free to ask them. I'll be glad to answer them. Bye.